So we are going to do summary on cos 10, 30, 45 and 60. Right, sine of 30 cos.
Yeah.
Sine of 45 meter. Josh, sine of 60.
Sine of 60, root 3 over 2.
Cos of 30 McCall.
Root 3 over 2.
Cos of 45 Bo. Were you here for these lessons? Were you here for the Yep. Good. Alright, 10 of 30, Robin. 1, 2, 3, 4, 5, 6, 7. Alright, 10 of 45, Josh.
1.
And 10 of 60, Amanda. Good. We feel like we're getting better at these? Good. Alright, 5 identities. Preferably in order. Alright, first one, let's go Robin. Okay, the tan of theta, which is sine of theta over cos of theta. Kyle,
I don't remember any of these.
can you tell me one of them?
No, I don't remember any of the
Josh, can you tell me another one?
I'll give you, I think it might be 5.
Yep.
1 in the quad is 6. Oh.
Josh!
It's crazy.
Stop here, Robin.
The one in the cot is cozy. That's how you remember it. It's very funny because my son's in a cot and I don't want to think he's sexy.
Whoa!
Right, another identity. Let's go, Robin. Okay, the cot theta is cos theta over sine. Right, so basically if you remember number 1 and number 3, you can then derive 2, 4 and 5. Okay, so if you remember tan of theta, which is sine over cos, okay, you would then flip that fraction over because cot is the reciprocal of tan. Okay, so you flip the fraction over and they're the values there. Alright, so if you don't remember how to derive them, well, that's pretty much how I did it. Okay, you flip that fraction over. Alright, number 3. McCall.
Sine squared theta plus cos squared theta is 1.
Good. Okay, so if you remember sine squared plus cos squared is 1. From that, if you divide everything by by sine, if you divide everything by sine, you will get equation 5. Okay, so divide everything by sine squared theta. So sine squared divided by sine squared, which is 1. Cos squared divided by sine squared, so it's cos over sine, which is cot. So we result in a cot squared. Right, and 1 over sine squared, and remember that third letter gives you that ratio. Okay, so if you don't remember 1 in the cot is cozy, okay, then you can derive it from this equation here. So that means number 4, when we divide everything by cos squared of theta, we will get that equation. Amanda. Okay, so if you divide everything by cos squared, the sine squared over cos squared is tan squared. Cos squared over cos squared is 1. And 1 over cos squared, take that third letter for that reciprocal. Okay, so either you can derive them, and I've shown you all these in that lesson, or you remember the one with the tan is sexy. Alright, 1 in the cot is cozy. Josh.
Yep. Robin.
Okay, so to do well in this topic, you need to be able to know all 9 plus 5 things there, okay? And extension students, especially you, because you'll be doing further work on those sort of things. All right, are there any questions on any of that? Okay, so hopefully everyone's getting better, okay, and be able to start spitting them out really quickly. All right, so we're on now page 50, and we're on 6.7. We're looking at the sine rule. So nobody remembers any non-right angle triangle trig they might have done in year 10?
No.
At all? Alright, so this is going to be new for you. So, trig is what you would have learnt so far is based on right angle triangle. We're now adventuring into the non-right angle triangle realms. Okay? So, first thing in your note. So each angle in the triangle is labelled with a capital letter, and their opposite sides are labelled with the same letter but non-capital. Alright, so if we draw a triangle, we go A, capital B, in clockwise or counterclockwise order. Will be for a triangle obviously, but when you do this for a quad or anything bigger, okay, you always need to have these in a clockwise or anti-clockwise order. Okay, and the side opposite that capital letter will then be notated by this lowercase equivalent. Okay, so the side opposite that angle is notated by the lower letter equivalent. Okay, and that is important, alright, because that's what the rules that we're about to do are based on. So, in any triangle A, B, C, okay, so we're rotating the capital letters of the vertex, we have the following formulas. Right, so sine of capital A over little a, which is equal to sine of capital B over little b, which is also equal to sine of capital C over its opposite side equivalent. So we have not seen these before. Is that correct? All right. Okay. Also, if you flip all your fractions over, because they're equations, if we do the same thing to both sides, we will also have a true equation. That's number one. Number two, do we have A over sine of capital A, which is equal to B over sine of capital B, which equals C over sine of capital C. Okay, they're your formulas. Right, let's have a look at a proof. First proof in this topic. I've already derived everything for you. So, proof 6.1. Okay, so let's show those results. So again, we've got a non-right angle triangle. Okay, so the oval length on the bottom is C. A, B, C, capital letters at the vertex, and then the opposite side has the lowercase equivalent. So this will be A, and this will be B. Okay, now from the apex of that triangle, so the apex means the top angle, sort of in the respective of the highest angle on this dimension. Okay, let's drop a perpendicular down to meet the base at some point there. Okay, so that is perpendicular. And let's call it little h. So that side is C, and this point there is D. Okay, so yes, it's not quite clockwise anymore, like in terms of point, but because we had to introduce a new point, that's different. Okay. Right, so we want to show these results. So let's go sine of capital A. Okay, so the sine of the angle at A, so we are referring to this angle here, equals what in terms of the variables on the diagram? Pardon? Oh. Using your right angle triangle work. There's your angle, there's the right angle. What's my ratio for sine? What 3 letters? Opposite, adjacent, hypotenuse, which are the 2 for sine. Opposite over hypotenuse. So what is the side opposite the angle marked at capital A? H. Opposite from the right angle, hypotenuse, and that little leftover side, it's adjacent. Okay, probably should have done that a different colour. Anyway. Right, what is the hypotenuse variable? B. Okay. Right, sine of capital B. So now we're referring to this angle on the right, and we're still using our right angle triangle trig. Alright, what are my 2 variables to put into the fraction? Okay, so opposite the right angle, opposite marked angle, which is H, and opposite the right angle, which is your hypotenuse, which is A. Right, can anyone see what I'm going to do next? Goes back to your algebra and equation skills. Pardon? Well, what's the one thing in common both those equations have?
H.
Right, so let's make them both subject. So, H is going to be B, lots of sine of the angle at capital A. And for this equation, H is also going to be A, lots of sine of the angle of B, capital B. Okay, so this is really still 1, this is really still 2, just rearranged. Right, so let's substitute equation 1 into equation 2. So we have B sine of A, so I'm placing H with what H equals on my other equation, which equals to A sine of capital B. Alright. Divide both sides by AB. On this side the B's will cancel, and on the right side the A's will cancel. Therefore, sine A over A is equal to sine B over B. And similarly, if I were to do sine of the angle at C, well, I can't really do that. I'll have to make the make one of these to the apex and do the right, the perpendicular, and do a similar setup. Okay, but hopefully everyone sees. Similarly, we also have sine of capital C over C, which equals sine of capital A over A, and also sine of capital B over B. Right. I'm not going to do the second example, second part of the proof. Just a slightly different triangle, but I think I'll show you just one, and that'll be enough. Okay, let's look at an application. Let's look at some examples. Right, some examples. Right, the question says find the length A. In part A, correct 2 decimal places. Okay, we need to find the variable little a. Okay, so what you're looking for is one angle with the opposite side length given, and either the variable which is opposite the another known angle, or in the next example we'll do, will be an unknown angle but the opposite side length known. Okay? So, I know this side and I know the opposite angle. Okay? So I know the angle and the opposite side. Here's my variable and I know the opposite angle. Okay? So this is an application of the sine rule. So, the angles involved are capital A and capital B. Alright? So the formula is the sine of capital A over little a, which is equal to sine of capital B over little b. Okay, so that's the general use of the formula. However, because we are finding a side length, okay, I'm going to put that variable on the top left of my equation. Okay, it just makes things easier in terms of rearranging. So, I need the variable a over sine of capital A, which equals b over sine of capital B. Okay, so once you've detected what parts of the triangle to use, you now need to substitute that into the equation. So, that little a is still a variable. Sine of the angle at capital A, so we're going to do a sine of 28 degrees is equal to b. So b will be this one here. So I'll replace b with the distance, 10 centimetres, and sine of the angle at B, sine of 81 degrees. Right, so again it goes to your equations work. I need A by itself. I'm dividing A by sine of 28. Okay, so that means I need to multiply both sides by sine of 28. So in other words, I am going to cross multiply that value over there. So that means A is going to equal 10 times sine of 28 degrees over sine of 81 degrees. Now you don't really need to write degrees, okay? I'm just trying to make the point. Right, let's put that in calculator. Make sure your calculator's in degrees mode. Should be a capital D on top layer of the screen. And we need that correct to 2 decimal places.
4.75.
Sorry?
4.75.
Okay, someone else verify? Yep. Alright, so diagram given in centimetres. Remember, you must include your units and have the correct rounding at the end of your question to avoid any further, potential loss of marks. Okay? Is there anyone here that did not follow that process?
Yeah, I think so.
So, basically it's another formula and you're applying that formula. Alright, B. Okay, so this time we're finding the angle at E, as described in the question. Okay, so there's two parts to your formula. Okay, so the first part was over here, so we relabel it, where sine is on top, and the second part is where sine is on the bottom. Okay, depending on what you're calculating will be which formula you would write down. Okay, so this time you are calculating the angle at E, so you are going to write that on top of your equation, just to save you extra work later. So, sine of capital E over little e. So, D or F, where do I have a known angle and a known opposite side? At D, okay, capital D and little d are known. So my formula is going to be sine of capital D over little d. Right. Sine of capital E, so that's the variable. Okay, so the variable should always be on the top left, so that way it will be nice and easy to multiply across. Okay, rather than having variable elsewhere, where it might look a bit more confusing and strange. Right, little e, so the side opposite, which is 13 centimetres, equals sine at capital D, which is sine 36 over 11. Right, couple of things you now need to do. First, we need to do what's over here. We need to bring up the denominator of the left-hand side and multiply it on the other side. So sine of capital E is going to be 13 times sine of 36 over 11. Okay, make sure you got that habit in terms of writing 13 times sine 36, not sine 36 times 13. Okay, if you're going to do it that way, you need to be careful how brackets are, etc., etc. Right, we don't put that in your calculator yet, because there's one more thing you need to do. So E, so I've got a sine, just like my right angled trig when I'm trying to find an angle using my sine, I need to do a sine inverse of 13 times sine of 36 degrees over 11. Okay, so you can go from writing down your substitution straight to this line if you understand what's going on. I'm just breaking up the steps. Okay, and we need now that to the nearest degree. So, 44?
Yeah, 44.
44? Right, 44 degrees to the nearest degree. Right, any questions on that before I go to my next point? Did everyone follow what's going on, how to apply it, and how to look out for it? Right, now, remembering. Recalling, we also have sine of theta, which is equal to sine of 180 take away theta. So this is going back to our quadrants work, where we did all student take calculus, where sine was positive in both the first and in the second quadrant. Okay? Now the reason why I'm bringing this up, my first diagram, right, you're given two angles, therefore there is only one value the remaining angle can be, correct? Okay? The second diagram, you're only given one angle, okay? We have calculated an answer based on the information in the diagram, but can everyone see that that is not necessarily the only answer for my diagram? Okay, because I've only got one angle, 3644, from that, 3644 and then angle sum. Okay, technically there are two possible values that could fit inside that this angle here. Alright, and that came from that formula there. Sine of theta which is the same as sine of 180 take away theta. Okay, so when we did our quadrants work and we moved the point P over to the second quadrant, alright, the ratios were the same. Okay, so E equals 44 degrees. So E is going to be either 44 degree or it's going to be possibly 180 take away 44 degrees. It's 136. All right. So can everyone please now do the following? Can anyone now do sine of 36 divided by 11 over 11, and then do sine of 136 over 13, and also our actual answer, sine of 44 over 13. Right. And note this what you have for your answers. Okay, maybe write them to 2 or 3 decimal places. They're all the same. Okay? So that is why we have to consider 2 possible answers. Right, both answers are possible because we don't actually know how long this side is here. Okay, so not knowing this angle, therefore not knowing that size, it is theoretically possible to have 2 values for the angle at E. Okay? So, your calculator will always give the acute angle, so the angle in the first quadrant. Okay, so that's how everyone got 44. If the question specifically says to find the obtuse angle, okay, you will need to do an extra step and go 180, take away the acute angle. Alright? So, normal application, you are just finding the acute angle. Only when it tells you to find the obtuse angle, you'll need to go an extra step. So for example, the obtuse is going to be 180 take away 44, which is 136 degrees. Only when the question asks you to though. Okay, it will specifically reference the obtuse angle. Right, that's the sine rule. Any questions on that? No? Right, let's have a look at the cosine rule. Okay, so again we have a non-right angle triangle. These rules still apply if it was a right angle triangle. Okay, because you'll have sine of 90 somewhere, and if you do sine of 90, it'll equal 1. Okay, which will have your basic sine ratio for right angle triangle. Okay, so this is specifically referencing non-right angle triangles. So, in any triangle ABC, we have the following formulas. So number 1, c squared, which is a squared plus b squared. Take away 2 times a times b times cos of c. Or you'll have cos of the angle capital C, which is going to be a squared plus b squared take away c squared over 2a.
Sorry.
Okay, a couple of things to note. Okay, so we're finding a side length C. Alright, we're going to square the other two sides. We're going to take away 2 times the product of the other two sides, and then take the cos of the angle opposite that C. Okay, if we're finding an angle, we're going to add the square of the two adjacent sides, take away the opposite side, and then we're going to divide by the product of the two adjacent sides to the angle at C. Alright? Alright, let's have a look at the proof. Alright, so similar to how I did my sine. ABC. And drop that perpendicular down. So we have 2 right angle triangles there. Right, so this distance is x. So the overall distance here is c. This part of it will be x. So therefore this distance from here to here will be c take away x. Okay, we need to break these up for a reason. So we have capital A over here, so referencing the big triangle, little a will be the opposite side up here. And then the angle capital B over here, opposite side to the whole triangle. That means capital B will be there. Right. And this, so where they join, that's a capital D, where the perpendicular goes down. Alright, triangle ADC. Right, so we're referencing this left triangle here, so, and this height H. So it's pretty much the same as before, but we had to break up these two sections here. Right, so cos of the angle at capital A. So which of my 2 letters reference the correct ratio for the triangle ADC? Yep, so adjacent and the x over b. Adjacent here, and then the side opposite right angle. There, okay. So adjacent over hypotenuse, it'll be x over b. And also because I'm given 3 sides of my right angled triangle, okay, I can naturally write Pythagoras out for that. So the hypotenuse squared, b squared, is going to equal the sum of the 2 shorter sides of the square, sorry, the sum of the square of the 2 shorter sides. Right. In triangles, so now we've got the right triangle, so CDB. Okay, so again, I want to write down cos of capital B. Okay, so we're going to reference this angle down here, because, okay, so what are my variables to make that ratio of the triangle here? So we're referencing this angle here, okay, that's your hypotenuse, that's the opposite, and this leftover side is adjacent. Okay, cos is adjacent over hypotenuse, c take away x, and the hypotenuse, this has a. Right, we also have Pythagoras. So we have a squared, which is going to be c take away x squared plus h squared. So you folks into right, 1, 2, 3, 4. Right, equation 1. So we have x, so we got b on the bottom, so I'm going to bring it up the top. So x equals b times cos of a, cos of capital A. We can come back to that in a moment. Alright, let's do a couple of examples applying it, and then I'll come back and we can work out the proof. Alright, so examples. So let's see. Right. So we need to find the variable at b. So you start where the variable is. So we have b squared. Then the other two letters. So this is a little a opposite the capital A, and this is little c opposite capital C. So it'll be a squared plus c squared. So the sum of the square of the other two sides. Okay. Take away 2 lots of the product of those same two sides. And then multiply by cos of the angle opposite the side in question. Alright, so equals a squared, so 5 squared plus b squared, which is 8 squared. Take away 2 times 5 times 8. So replacing my variables with the numbers that from the diagram, times cos of 30 degrees. Alright, so you need to be careful with this formula, and this is a common error. Alright, the subject of your equation is a b squared. Alright, so what you will need to do is then take the square root of all that. So 5 squared plus 8 squared, take away 2 times 5 times 8 times cos of 30 degrees. Okay, so that's the next thing you will need to do. Okay. The alternative, or from this line here, can someone please put in 5 squared plus 8 squared, take away 2 times 5 times 8 times cos of 30 in your calculators, please. Is that on there?
Without the square root.
Without the square root.
I got the square root.
I want it without the square root, please.
It's 19.7.
Keep going.
19.71796.
That'll do. Alright, so the alternate is to write an approximation on there, okay, and the dot dot dot, showing that there is more to the answer than you're not showing, and then you write b equals the square root of that. Okay, so take the square root, so you should be able to push square root answer equals, that will do, okay, and then the question asks you specifically to 2 decimal places, so 4.44 centimetres. Okay, so we're not rounding till the end. Okay, so I'm not going to have this answer here 2 decimal places and then take the square root, okay, because that will have a rounding error. Okay, we do not round our answers until the final, till the very end of the answer. Okay, so when you push equals for that section, you should be able to push square root and then answer. So the answer is whatever's displayed on the result of the last calculation you've done, and then you will have that as your answer. Okay, otherwise, the next line you need to write is the square root of all that, and then put that as it is in the calculator, and you'll get the same answer. Alright, let's go B. So at least get these questions done. Alright, we're going to find the size of the angle PQR, that angle there. Okay, so we can also use the cosine rule to find the length of the side and an angle. Okay, we have to use the cosine rule here because we have no angles at all in the diagram. Okay, so I'll show you the difference and which rule to use next lesson. Right, so we're finding the angle cos of Q, so cos of capital Q. So we've got little r, we have q, and little p here. Right, so it goes the following. So we have the two adjacent sides of the angle, so we've got r squared plus p squared. Take away the opposite side squared for the marked angle. The two adjacent sides, the sum of the squares, and then take away the opposite squared over 2 RP. Okay, 2 times the product of the two adjacent sides. So r squared, so 15 squared plus 10 squared. Take away 6 squared over 2 times 15 times 10. Alright, and then in the formula you have a cos of Q. Alright. So Q will equal cos inverse of all that. 15 squared plus 10 squared, take away 6 squared, over 2 times 15 times 10. Alright. So, nearest degree. What do we get? Now shift cos of that. Yep. 50.
10 degrees.
15.3, 15 degrees.
Yep.
16 degrees around.
So it'd be 16
Yes?
degrees.
16 degrees around.
Oh, is it? Alright. So that now covers up to 611. I'll finish that proof next lesson. I'll sit down and do it myself again. Okay, tomorrow. Alright, so I'll see you extension students tomorrow morning.